lecture on the between keyword operator. The between operator can be used to match a value against a range of values. So for example, we can ask, where is a value between a low and a high? And this is essentially going to be a condition you can tag along with a where statement. You should note that using the between operator is essentially the same as asking individually where a value is greater than or equal to low and a value is less than or equal to high. So note that the low and the high here are both inclusive. So it's actually including the endpoints there. You can also combine the between keyword with the not logical operator, essentially asking where is the value not between low and high. And this is the same as asking value less than low or value greater than high. Note here that we are exclusive of the actual low point and high point. So what I mean by that is for the not between statement, if you're saying something like value not between 8 and 9, if a value happens to be 8, it's not going to be included in the not between. Versus, if we take a look back at the between statement, that is inclusive, meaning if you wanted a value between 8 and 9, it would actually include 8s and 9s there. So keep that in mind. And if you want to change exclusivity versus inclusivity, you can just go back and use the AND operator and then specify less than or equal to manually yourself with the comparison operators. Now, the between operator can also be used with dates. You should note that you need to format dates, in this case, in the ISO 8601 standard format, which is essentially just 4 numbers for the year, a dash, then 2 numbers for the month, a dash, and then 2 numbers for the date, or the actual day. So that means it would look something like, where is the date between, and then as a string with single quotes in that particular format, year, 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 dash, month, month, dash, day, day, and then the other date. Something to keep in mind is when using the between operator with dates, that also include timestamp information, so not just the actual day, but also the hour, minutes, and seconds. You should pay careful attention to using the between operator, especially since we have that issue of inclusivity versus exclusivity of the not between. So you should take into account the fact that a date time, that is both the date and the actual time information, would start at 0-100 hours. So that may have an effect depending on what the actual situation is and whether you want inclusivity or exclusivity around that midnight time or 0-100 hour time. Later on, we're going to study more specific methods to actually work with date time information types. So don't worry about it too much right now. It's just something to keep in mind for the future. Let's go ahead and get some quick practice with the between operator in pgadmin. Okay, here we are at pgadmin. What I'm first going to do is check out the payment table, since that's what we're going to be working with for our examples. We'll say select from payment table. We'll grab everything, but just limit it to just a few rows so we can see the general syntax here and general columns. We have the payment ID, customer ID, staff ID, rental ID, and then the amount and the payment date. So we're going to be working with these 2 columns here. Let's go ahead and see if we can use between on the amount column. Let's imagine we wanted to know the actual number of payments that were done between $8 and $9. So what we can do is say select from payments where amount between 8 and 9. If I just run this, it'll give me all the results. So we can see everything here is $8.99. And if I actually wanted to know the total number of transactions, I can just count the number of rows returned, and it's 439 rows. If I wanted to know the opposite, essentially everything that wasn't between $8 and $9, I can simply add not between 8 and 9. I can run this, and then I get the number of payments that were not between $8 and $9. Let's take a look again now at the payment date column. So what we can do is, let's imagine I wanted all the payments that happened on the first half of February of 2007. What I could do is, let's just select everything so we can get an idea of what's happening here. And we'll say where the payment date column is between, and what we're going to do here is make sure we format this correctly, which is going to be the year dash the month dash, let's say 01, and we'll say 2007 dash 02, and then the 15th. So we run this here, and we can see all these payments happened between the 1st of February 2007 and the 15th of February 2007. Now, something to keep in mind, especially when you're dealing with timestamp information, is that this timestamp information includes both the date and hour, minutes, etc. So that means PostgreSQL essentially has to decide, does a day start at 0-100 hours or at 2400 hours? And if you're dealing with exclusivity versus inclusivity, that actually might affect your logic. So what I mean by that is, take a look at the results here. They all actually happened on the 14th. So if you kind of scroll down, you'll see there's 27 rows, and essentially all the payments that happen between the 1st and the 15th all happened on the 14th. Now let's actually switch this to be all the payment dates from the 1st to the 14th. And this is where students often get confused. They would actually expect to see these results. But if I run this, you'll notice nothing gets returned. And that's because when we're dealing with this end date, it's actually only going up to the 0-100 hour mark. It's not going to the end, which would be the 2400 hour mark of the 14th. Which is why for these sort of between statements, when you're dealing with timestamp information, you just have to be careful of that. So you always want to double check and make sure you're getting the results that you expected. So in this case, I'd have to go all the way to the 15th to actually include information that happened on the day of the 14th. Okay, and later on, we're going to learn a lot more about how to deal with timestamp information such as this. So that's it for the between examples. Coming up next, we're going to learn about a couple more SQL keywords that are very helpful in different types of queries. I'll see you there. The user's name shows up in a list of known names. So instead of having to write a bunch of OR statements, such as name is equal to David, or name is equal to Claire, or name is equal to Zach, we could use the in operator to just create a condition that quickly checks to see if a value is included in a list of multiple options. So you can check something like, where name in Zach, David, and Claire. So the general syntax would be something like this: value in, and then a bunch of options. So, for example, an example query could be select the color column from table where color in red, blue. So note here that the options are in this little list in parentheses, and then we use the in operator to basically specify that we're checking for the color condition that happens to be either red or blue. So these are a bunch of OR statements. So anything red and anything blue will be returned to us. And we can always expand this to more options quickly. So we can say now where the color is red or blue or green. So essentially there's a little OR statement in between all these. Keep in mind you can also combine this with the not operator to essentially do this excluding these values. So where color is not in red or blue. So essentially every color that is not red or blue. Let's go ahead and quickly see some examples in pgadmin. Here we are at the query editor. I'm going to take a look at the payment column, or a payment table. We'll just select everything from payments. Let's just limit this to 2 rows so we can take a look at the result here. And notice we have an amount column. Let's first figure out what are the actual distinct values that are available to me in the amount column. So what are the unique amounts that we're charging? So we can say distinct amount from payment, and I'm not going to limit this since I want everything back. I run this and I can see I have $10.99, $1.99, etc. And what I could also do, just for clarity, is order this by amount, as we've seen before, and now I can order amount 0, 99, etc. So maybe I want to figure out all the orders that happen to be 99 cents, 198, and 199. So how could I do that? Well, what I could do is I could select any columns I want, or everything from payments, and then we'll say where the amount is in, and here we'll go ahead and specify 99 cents, 198, 199. Note here that I'm not using strings or quotes because this is a numeric data type. So if we go ahead and run this, we get back a bunch of values where the amounts happen to be in 199.99 or later on 198. And if I wanted to figure out how many payments actually occurred that happened to be one of these 3 values, I could run this and I get back that there were 3,301 payments. Now let's imagine I wanted the actual opposite information. I wanted to count out how many payments were not 99 cents, $1.98, or $1.99? Well, there's a couple things I have to do here. First, notice here again I have the parentheses of that list of options. If I just add not in front of this and run this, then I get back the amount that is not in 99 cents, 198, and 199. So there's 11,295 payments that are not these three values. And let's go ahead and explore this on a string column to finish this off. We'll just say select everything from customer. Take a quick look at this. I have the first name and last name. So let's go ahead and select all the columns from customer where the first name is in, and let's just give some options like John, Jake, and Julie. We'll go ahead and run this, and here I can see there was no one named Jake in this particular table, but we did have a Julie and we did have a John. Okay, so that's the way the in operator works. Main things to keep in mind is that you're using parentheses here and then commas to separate out your options, and your options should be matching the general syntax of the column. So we want to make sure that for numerics, we're providing numerics in the list, and for strings, we're providing these single quote strings here. And we can always say not in if we wanted to see essentially the exact opposite. All right, that's it for this lecture. I'll see you at the next one. Back everyone to this lecture on like and ILIKE. And really it's more than just these two keywords. This lecture is about using pattern matching with string data. We've already been able to perform direct comparisons against strings, such as where first name is equal to John. But what happens if we want to match against a general pattern in a string? That enables us to answer questions such as all emails ending in @gmail.com, or all names that begin with a capital A. The like operator allows us to perform pattern matching against string data with the use of special wildcard characters. So there's two main wildcard characters we're going to cover right now, and that is the %, which matches any sequence of characters, so essentially any number of characters. And then there's the underscore, which matches any single character, essentially a wildcard for just a single character inside of a string. So let's see a couple of examples of this. We'll start off with the %. So the % is a wildcard character for any sequence of letters or characters. So this basically specifies something like all names that begin with a capital A. So we would say where name, like, and then a string where we have the capital A and then the %, essentially saying you'll match with anything that starts with a capital A and then has any number of sequence of characters after it. Then we could do something like all names that end with a lowercase a. So then we have where name, like, and then we start off with the % and end with a lowercase a, essentially saying that anything or any sequence of characters can come before that lowercase a. Notice I've been saying things like uppercase or lowercase, and that's because like is case sensitive. However, you can always use ILIKE, which is going to be case insensitive. Now using the underscore allows us to replace just a single character. For example, let's imagine we were storing the Mission Impossible films and they were titled something like Mission Space Impossible Space and then 1, 2, 3, or 4, etc. So we could do something like where title like and then Mission Impossible space and then the underscore just leaves a single wildcard place to fill in whatever number we're looking for. Now you can use multiple underscores. So imagine we had a version string codes in the format, something like version numerical or hashtag A4, and then version hashtag B7, etc. So that would be something like where value like version hashtag and then 2 underscores, where those 2 underscores can be filled with any sort of characters you want. So this essentially leaves open any 2 characters to fill in those specific underscore positions. Now what's nice about this is then we can begin to combine pattern matching operators to create more complex patterns. So take a look at this example where we say where name, like, and then underscore HER %. So if we think about what this is actually asking for, this is returning back, and we've color coded it here, a single wildcard space for the first letter. And then after HER, any sequence or any number of characters can occur. So here we have Cheryl, which starts with a single C, then HER, and then has 2 characters after that. Or Teresa, which has a capital T, H-E-R, and then E-S-A. So notice here, it has to be just one character before H-E-R, but then any number of characters after it. So this allows for really powerful pattern matching code. Now we're just focusing on like and ILIKE and those two wildcards of an underscore and a percent sign. But in case you're familiar with something called regular expression or regex in other languages such as Python or C++, I want you to keep in mind that PostgreSQL actually does support these full regular expression capabilities, and you can check out the link here or just go to the docs and look up functions matching. And not only does it have information on like and ILIKE, but it also goes into much more detail on regular expressions. We're not going to cover those for right now. Instead, we'll just focus on like and ILIKE. Let's check out some examples in pgadmin on our own DVD rental database. Okay, here we are at the query editor. Let's imagine I wanted to figure out how many people actually have a name that starts with J. Well, I could say select, and we'll start off by selecting everything from the customer table, and we're going to check where their first name is like, and then notice here I'm going to say capital J and then percent sign. And then if I run this, I get back the results for everyone that has a first name that starts with the letter J. And if I wanted to actually figure out how many of these there were, I could simply just provide a count on the number of rows returned, and I get back there are 65 people who have the first name that starts with the letter J. Now I can keep adding on to this, so then I could say something like and last name like, and let's go ahead and do something such as starts with an S. And I'm not actually sure if there's someone like this, but we can run this and check. Okay, it looks like there's 5 people. Let's go ahead and explore those names. So just grab all those rows for those customers, run them, and here we can see there's Julie Sanchez, Jeffrey Spear, etc. Okay, so that's how it worked for the percent sign. And notice here that I had to make sure to use capital J because I'm using like. If I were to lowercase one of these and run this again, I get back nothing because this is case sensitive. Alternatively, if I don't want to worry about case, I can use ILIKE, run this, and it'll return back the results. Whoops, accidentally changed this to J. Let's go ahead and change that back to S. Run that again. Okay, so there we go. ILIKE is case insensitive, which means it doesn't matter if I use the lowercase j here or a capital J and a capital S. I run this again, it's going to be the same result either way. So ILIKE is case insensitive, like is case sensitive, just something to keep in mind. And we can always add in more than just a single wildcard character. For example, we could do something like this. I can say first name, like, and let's imagine I wanted to figure out people who have the sequence of characters ER somewhere in their name. So I could do something like percent sign, ER, percent sign. I run that. And basically what that's asking for is anyone who has ER somewhere in their first name. Now notice it'll return something back like Jennifer. So ER is at the end of Jennifer, and this sequence of characters can also be nothing. It can be 0. So that means ER just has to show up anywhere inside this name. So Kimberly has the ER here in the middle, Catherine does as well, but something like Heather has it at the end, and that still is okay with this sort of code. So just because it has a percent sign doesn't mean it has to fill in something there. It can be blank. And we can keep doing this. Maybe we want something like her somewhere in the name. Run that, and I can see Catherine, Heather, etc. Or we can do what we did in the slides, which is replace one of these with a single underscore, which means only one character is now allowed in that space. So now when I run this, I only see back Cheryl, Teresa, Sherry, and Sherry with an I. So note the difference here is now only one character is allowed before this HER. Something that's also important to note, and we'll finish this off, is to show you that you can also add in the not operator to essentially get the opposite. So I can say, give me everything that's not like this, essentially everyone that isn't these 4 people. So I can just run this, and here I see everyone that wasn't in that list of 4 people. We then can combine this with things like logical operators such as AND. So I could do something like, let's say we're first name, like, and let's say it has to start with an A. So we go ahead and run this, and we can see everyone whose first name starts with an A, and let's go ahead and order it by the last name. So we can start kind of getting more complicated here. Order by last name, run this, and now I can see Alma Austin, Angel Barkley, Agnes Bishop, etc. But let's imagine for some reason I didn't want anyone whose last name started with a B. So I wanted to remove Barkley, Bishop, Bradley, Burns, and Butterfield here. Well, I can begin adding things. So where first name is like A, and then we can say something like, and last name not like, and then we'll say starts with a B. So we go ahead and run this, and now I can see I got rid of those people that had a last name that started with a B, and yet retained everyone who has a first name that starts with an A. So you can begin to create really custom patterns for whatever you're looking for with just these wildcards. So keep in mind you always have the % and the underscore available to you. % for a long sequence of characters, underscore just for a single replacement character. All right, thanks, and we'll see you at the next lecture. Hello everyone, and welcome to your first general challenge lecture. So I'm really excited for you to take on this first general challenge because these general challenge tasks are going to utilize all the skills that you've learned so far. You'll receive the general challenge task, and then you'll get hints to the challenge and then the solution to the challenge. These challenges are going to be a little more difficult than what you've seen earlier, so try breaking down the problem into